Good morning, sir. My name is S. Chetan Kumar Reddy. Subject Signal Systems and Statistic Process. Roll number 2440904030. Branch ECE section. My topic about relation between cross power spectrum and cross correlation function. Introduction to cross analysis. The cross power analysis, the cross power spectrum and cross correlation function are fundamental tools in signal processing and data analysis. They are used to study the relationship between two signals or data sets in different domains. Understanding their connection helps in analyzing how signals relate in frequency and time domains. Definitions of cross power spectrum. The cross power spectrum measures the distribution of power between two signals as a function of frequency. It is obtained by taking the Fourier transform of the cross correlation function. It provides insight into shared frequency, components and phase relations between signals. Definitions of cross correlation function. The cross correlation function quantities the similarity between two signals as a function of time lag. It is computed by sliding one signal over another and calculating the inner product at each position. The function revolves how one signal relates to another over different time delays. Mathematical relationship overview. The cross power spectrum and cross correlation function or Fourier transform Fourier transform pairs. So specifically, the cross power spectrum is the Fourier transformer of the cross correlation function. Conversely, the inverse Fourier transform of the cross power spectrum yields the cross correlation function. Formula mathematical expressions. If r of xy into tau is the cross correlation function, then its Fourier transform s of xy y into it is the cross power spectrum. Mathematical expressions formulas. The inverse Fourier transform of the cross power spectrum gives the cross correlation function. The relationships highlights their dual nature in the frequency and time domains. Physical interpretation of the relationships. The cross power spectrum revolves dominant frequency components shared by signals. The cross correlation function indicates the time delay or lag at which signals are most similar. The mathematical connection allows analysis in the domain best suited for the specification application. Practical computation steps. First, compute the cross correlation function from the two signals in the time domain. Next, apply the Fourier transform to obtain the cross power spectrum. Ultimately, compute the Fourier transform of signals first, then multiply to get the spectrum directly. Applications in various fields. In communication studies, tools help identify shared signals and delays in channels. In astronomy, they analyze signals from different sources or sensors. In biomedical engineering, they examine relationships between physiological signal over time in frequency. Summary of key points. The cross power spectrum cross correlation function of Fourier transform or pairs. They provide complementary insights into the frequency and the time domain relationships between signals. Understanding these relationships is essential for effective signals analysis and interpretation. Conclusion of further reading. Mastering the relationships enhances the analysis of complex signals across disciplines. Further reading includes textbooks on signals processing and especially research articles. Leveraging both tools can lead to richer insights into the dynamics and interactions of signals. Thank you for the chance.